We've got it on there now. And let me share my screen. And on my screen, I want to start with this OneNote. Is that legible enough for you guys? Do you need it bigger, darker, or is that all right?
That's good.
That's good.
So today, last class, we started talking about subsets, but we didn't get into proper subsets or the number of subsets the second half. We'll be looking at that today. You need all of that information for homework too. There is a quiz today on the content from homework 1. I had decided rather than giving it during class time, you can take it at any point in time today before 11:59 p.m. It's very brief, 5 questions, mostly multiple choice. With this one, you don't need to work. Realize because it's a quiz, you'll only have 1 chance at it, and you won't have any help functions, and you'll have 15 minutes.
I got a question.
Okay.
Sure.
Do we have to show work on our homework?
No, you only have to show work on tests. However, I would strongly suggest when you do your homework that you do have a homework notebook and you do the work pencil and paper, because that way you'll have something to study from before a test or quiz. But again, that's personal preference. Force you to.
Wait, so where is this quiz going to be, in math lab or?
It's in math lab.
Okay.
All right, it's in math lab. I do believe it should be right after homework 1. I think I dragged it into place there.
Oh, the quiz due tonight?
What?
The quiz due tonight?
Yes. I was going to give it class time, and I decided rather than giving it class time, that I would just give you guys till the end of the day. So if that's problematic for anybody, please contact me. Before we get started, from where we left off looking at subsets, does anybody want me to open my labs? Does anybody want to look at any questions from the homework? Oh, and also I forgot to say this. Is there anybody who's been having technical difficulties with the site? Has everybody, pardon me, been able to the My Lab? And if you haven't gotten an access code yet, hopefully you've been able to use that 14-day free trial. Does anybody have any technical issues with My Labs, or does anybody want to look at any of the math of the problems in I do believe since we last met, I moved back the due dates on that homework too, because we had not yet finished the content last class. So if there are no questions, we left off talking about subsets. And just as a quick refresher, if I say that A is a subset of B, can anybody remind me of what that means?
The set B is in A.
The other way around. A is in B. All of the elements of A are in B. But right idea, just realize that order matters, okay? Today we're going to expand that a little bit and look at one particular type of subset, which is a proper subset. So if A and B are both sets, we say A is a proper subset of B, and that will write A is a proper subset of B if, oh, I apologize, I should white cursor. Never read that. If you want to stop for a second, I'm talking to a meeting full of intelligent college students. I want everybody to take a minute and compare this statement, A is a proper subset of B, to this statement, A is a subset of B. They sort of look similar, don't they? What's the difference?
Is the symbol separating them?
The symbol separating them, what's missing is that little equal sign down below. Oops, I didn't mean to put that up. Is that little equal sign down below. And so actually the difference between subset and proper subset is very much like the difference between if I were to compare the symbols for less than and the symbols for less than or equal to. So for A to be a proper subset of B, A is a subset of B. But A cannot equal B. A is not equal to B. So everything in A is in B, but the two sets cannot be equal. So let's look at an example. Let's have A be the set L, E, T. Let's have B be the set L, E, T, R. And let's have C be the set R, E, L, T. From last class, is everybody all right if I say A is a subset of B? Every element of A is also an element of B.
Yes.
Mm-hmm.
Does A equal B? Do they have exactly the same element?
No.
Mm-mm.
So can we say that A is a proper subset of B? Everything in A is in B, but the two sets are not the same. Is C a subset of B? Is
No.
everything in C, R, E, L, T, also in B, L, E, T?
Yes.
Does C equal B?
Yes.
Yes. So we'll say that C is not a proper subset of B because the two sets are equal. In the same way, we could say,
So
go ahead.
I'm sorry. So whenever they're both equal to each other, they'll never be proper subset.
Beautiful.
Okay.
Spot on. So we can say that B is a subset of itself, but B is not a proper subset of itself because it's equal to itself.
Okay.
We also, last class, we had said that the empty set is a subset of every set.
Excuse me.
However, the empty set is not a proper subset of one set, and that's the empty set. That's the only set that the empty set is not a proper subset of. So the empty set is a subset of every set. It's a proper subset of every set except for itself, except for the empty set. So, fine line of difference between subset and proper subset. But when I look at these symbols, subset, proper subset, this one's got the equal sign. It's okay if it's equal. And it very much reminds me of the relationship between strictly less than, or equal to. This one, it's okay. Does everybody see the similarities between the two symbols?
Yes.
Yes. So it's a regular subset if the equal sign's underneath. It's okay if they're equal. If there's no equal sign underneath, it's a proper subset. And the two sets, the first one has to be contained in the second, but they cannot be equal. If that's all right, the other thing that's in this section 2.2 is the idea of how many subsets and how many proper subsets does a set have? And so we're going to see there's a formula for this. But I was always the type of person that unless a formula made sense to me and I could sort of see the why of it, I wasn't real good at retaining that formula. And so I'd like to take a couple of minutes, kind of show you with some examples why the formula works. And so first example I'd like to look at is the empty set. First thing I want to know is what's its cardinality. What's the number of elements in the empty set? Is there anything in that empty set?
No.
No. So is everybody right? We can say that it has 0 elements.
Yes.
Now I want to look at its subsets. I want to list them and I want to specifically say how many does it have. And if we're looking at regular subsets, is everybody all right? If it can be a subset of itself, and so it has that one regular subset. And then if I ask how many proper does it have, would it have any? No. Next example, I'd look at a set A, which just contains the letter A.
What do you mean by proper?
Proper subset, like we just said, in order to be a proper subset, it has to be a subset, but it can't be equal. So over here, if I look at the empty set, the set that has nothing in it, its only subset is itself, and they're equal, so it has no proper subsets. I think with the next two examples, the difference will be a little bit clearer. Let's look at the set A that contains the letter A. What's the cardinality of A? How many things are inside this set? One. Beautiful. Now, if I wanted to list the subsets of that set, there's the empty set. And is everybody all right? if I'm talking regular subsets, the set itself. So this one has two subsets. Now, when we talk about a proper subset cannot equal the set itself. And so do you see one of the subsets is equal to the set? And so this will only have one proper subset. We have to take away the set itself.
How does it have two subsets?
Because the set is a subset of every set. And so,
Okay.
okay, do you remember empty set is a subset of every set?
Yeah.
Okay, let's look at the next example. We're going to get a little bit more challenging. Let's say B is the set that contains A and B. How many things are inside of set B? How many elements does it have?
One. Wait, no.
Two.
Two.
Now, if I wanted to list the subsets, empty set is a subset of every set. Can anybody think of any more subsets that this set A, B would have?
Would it be B?
Oh,
Could have a set with just the letter B. Anything else?
A.
Just the letter A in it. Anything else? Can it be a subset of itself?
okay. Yeah.
So how many subsets does this one have?
4.
4. And then when we talk about a proper subset, does everybody remember, it can't be the same as the original set to be the proper subset. So we'd have to take one out. So how many proper subsets does it have?
3.
3. Beautiful. And one more just to prove a point. Let's have C be the set A, B, C. What's its cardinality? How many things are in that set?
3.
3.
If I were to list its subsets, there's the empty set. What else could it have?
Bless you.
Bless you.
A.
A.
Anything else?
B.
Just B, beautiful. Anything else?
C.
Anything else?
A and B.
A and B. Anything else?
B and C.
B and C, I like it. Anything else?
A and C.
A and C. And I think there's one more,
A, B, and C.
the whole thing. And so that gives us 1, 2, 3, 4, 5, 6, 7, 8 subsets. And of those 8 subsets, how many are proper?
7.
7. We have to take one away. Now, this is sort of a fun game. You could do it all day long if we wanted to, but I think there's enough here for you folks to notice a pattern. Do you see every time the number of elements went up by 1, every time I added an element, what happened to the number of subsets?
They go down by 1, or decrease by 1.
Okay, the number of proper decreased by 1. The first set had 1 subset. The second had 2.
They doubled.
Multiplies.
Oh, okay.
But you see that every time I add an element, the number of subsets doubled. And so
Okay.
if I look for the formula for the number of subsets, a set can have, are we all okay with the idea that since it doubled, it has to somehow involve the number 2? And the way it involves the number 2 is it's 2 to the n, where n is the cardinality of the set. And then I think we all notice when I take one away from that, it gives me the number of proper subsets. I want to backtrack for a minute. Let's see if I can get all fancy here and change colors. If I had 3 elements, the number of subsets should be 2 to the third. Well, 2 to the third is 2 times 2 times 2, which does give me 8. When I had 2 elements, the number of subsets is 2 to the second, which is 4. When I had 1 element, the number of subsets is 2 to the first, which is just 2. And the one thing I'm not positive everybody's familiar with, has anybody ever seen 0 as an exponent? When your exponent is 0, it will always equal 1, except for if I had 0 to the 0. 0 to the 0 is undefined. But any number to the 0 power is equal to 1. So the empty set will have 1 subset. And then we notice that the cardinality is 1 less. So let's look at some examples. Let's have B be the set A, E, I, O. And I want to know how many subsets does B have? And how many of them are proper? The formula for the number of subsets is 2 to the n, where n is the cardinality. So I guess the first thing we have to do is we have to count. What's the cardinality of V? How many things are in set V?
Third.
A, E, I, O, U. I think there are 5.
Yep.
We're going to have to take 2 to the 5th. And 2 to the 5th is 2 times 2 times 2 times 2 times 2. We're multiplying all those 2's. Does anybody have a calculator handy to find the value of that?
It's 32.
It's 32. So if it has 32 subsets, how many of those are proper?
31.
31. Now, I'm positive with this one, it's not too tough going 2 times 2 times 2 times 2 times 2. But with other examples, let's say C is the set of consonants. The letters that aren't vowels. And I want to know how many subsets. And how many of those are proper?
Bless you.
Thank you.
Well, how many consonants are there? There's 26 letters in the alphabet, 5 of them are vowels. How many are consonants? Six minus 5 would give us 21. When we take 5 vowels, so the number of subsets would be 2 to the 21st power. Now, if I were to take 2 to the 21st power, is there anybody who wants to sit and multiply 2 by itself 21 times?
No.
No. I don't either. So I'm
That
gonna
would take forever.
I know. I'm going to stop screen sharing for a moment. And can you guys, is it just showing my screen, or are you guys just seeing a little square? Oh, dang it. Does anybody know how to undo that? Let's see.
Uh, Should just like press, I think you can just press like the start button.
I think if I press speaker view, so if you can all like in your corner, press speaker view. Can you all see my calculator now?
Yes.
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 Okay.
Yeah, anyway.
This is, my desk is in a not very bright room. Is that any better? So when you're doing an exponent, this is the calculator that I would recommend you buy if you're going to buy a calculator. It's cheap and it has everything that you need. So when I'm taking 2 to the 21st power on my calculator, first I'm going to turn it on and clear what's in there. Then I'm going to type the number 2. And then as you look at the buttons on the left-hand side, partway down, there's a button that looks kind of like it's just an arrow pointing up. You guys see what I'm showing here, the arrow pointing up? It's considered a caret up. And so now you see I've got 2 caret up, and then I'm going to type in my exponent 21. When you use that caret up button, the very next number that goes in is the exponent. So this is going to give me 2 to the 21st power. And so now when I hit equal, I get a very, very, very large number. I have to apologize, I can't read it in that, so I'm going to go back to screen share. And so 2 to the 21st, what I'm getting is 2,097,152 subsets.
That's a lot.
Okay, so do you guys want to start listing them? No, that was a bad joke. Of those, how many are proper? I'm going to just take one away, so that gives me 2,097,151. And I'd like to look at one more of these. This time, let's say S is the set of all x such that x is less than or equal to 100 and x is a natural number. First thing I want to know is what's the cardinality of S? How many natural numbers are there? Less than 100.
90. Oh,
If we're including 100, I think it's
100.
100. So the number of subsets would be 2 to the 100th power. Now I'm going to take my handy dandy calculating machine. 2 caret up 100 equals. And what the heck is going on here? When I type that in my calculator, I get 1.26760506. How can that be a decimal number? And you guys want me to show you my calculator, or will you trust
I got
me?
a question.
Yeah.
Wait, where you get that 2 from?
This number 2?
Yeah.
Because when we listed all of the subsets, did you notice that every time we added an element, the number of subsets doubled? And so the formula for the number of subsets will always be 2 to the nth power, where n is the cardinality. So that's just the part of the formula for the number of subsets. So with the crazy decimal, in fine print down below, and I've got old people eyes, so I really have to squint for that. It says times 10, and then there's a 30. And so if you're expecting a large number and it gives you a decimal, look at this stuff in the back. What happens if my answer is in scientific notation? It's actually 1.26765606 times 10 to the 30th power. And I'm guessing you've all heard of scientific notation before. That 10 to the 30th power means I'm going to take that decimal point and move it back 30 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm getting tired of doing this. So you get the picture. It's really a very large number. It's a number with 31 digits in it. And so I just wanted to give you a heads up that sometimes if it's going to be a very, very large number, if you get something like that, don't think you did something wrong. It just means that your calculator's throwing it in scientific notation. I don't think you're going to run into any like that in the homework or on the test. If you do run into any that's that large, you're probably best off just writing it exponentially so that this would be a sufficient answer. All right? But if you get something that looks like that, don't panic. It just means that you've got scientific notation. So, in terms of subsets, you need to know what a subset is. You need to know what a proper subset is. And you need to be able to find the number of subsets that a set can have. Everybody comfortable with those three things?
Can we just go over proper subset? Like, what is a proper subset one more time?
Sure. Let's say that I have a set A, and let's say A contains 1, 2, 3, 4, 5. And I have a set B that contains 1, 3, 5. And I have a set C that contains 5, 4, 3, 2, 1. Is B a subset of A?
Yes.
Yes.
Does B equal A?
No.
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 So we can say that B is a proper subset of A because everything inside of B is in A, but they are not equal. So far, so good.
Yes.
Is C a subset of A? Is everything in C inside of A?
Yes.
Yes.
Does C equal A? Do they have the exact same elements?
Yep.
Yes.
So C is not a proper subset of A because they're equal. Is C a subset of B? Is everything C and B? No. So is it all right that C would not be a proper subset of B because C's got more stuff in it than B does? So to be a proper subset, it has to be a subset that is not equal to the other set. Better?
Yeah.
Great. If that's all right, then we're going to take, we've got about 15 minutes left, and I'd like to take 10 minutes to just do a really little introduction into what some of what we're going to be looking at in that next section, Chapter 2, Section 3. So, Chapter 2, Section 3 deals with set operations. And when I talk about set operations, I'm not talking about things like surgery. Whenever I write that, I picture that game from when I was a child, Operation. But no, that's not what I mean. I mean operations like, you know how normally with numbers we have operations like addition and subtraction and multiplication and division? There will be operations on sets, but they're not going to be like those operations. They're going to be a little bit different. And before we define set operations, we're going to start looking at something that's called a Venn diagram. Because Venn diagrams help us visualize our set operations. Now, a Venn diagram is a diagram that shows the relationship between sets. And so, yes, if it's a diagram, you're going to be drawing. Just giving you a heads up, if you look at the diagrams I draw, you can see why I teach math and not art. I don't take off for artistic value. They don't have to be the world's prettiest drawings. They just have to be clear enough for us to determine the relationship between the sets. Before we start drawing the Venn diagrams, we have to have a couple of definitions under our belt. And the first is going to be that of the universal set. The universal set is going to be defined as the set of all elements being considered. The universal set is usually abbreviated with an uppercase U, but it's got a tiny little tail on it. It's kind of like a script U. It's not real blockish. It's got to have that little tail. And later on, probably on Friday, you'll see why it's important that the universal set isn't a real block looking U. So that would be the universal set. And so, for example, if I say that S is the set of students in class, let's try, how do you spell students? Oh my heavens. S-T-U-D-E-N-T-S. Sorry about that, in class. Well, my universal set might be all of the students at NCCC. And so it's a bigger group that contains everything that I might be considering. When I look at a Venn diagram, we're going to always start by first drawing the universal set as a rectangle. And so the rectangle is usually labeled with a U for the universal set, unless of course your universal set is got a different name. And so now what happens is we put other sets in the universal set, as loops. And so if I look at the example that we have with our universal set being all students at entry, well, if you're a student in this class, aren't you also a student at the college?
Yes.
And so we'll take that set of students in this class and put it inside the universal set. All right? So let's look at another example. And in this other example, can I turn the page, folks? I'm going to. When you fill in a Venn diagram, the general rule of thumb is to start at the innermost part and work your way out. What the heck does that mean? Let's say, for example, I have a universal set that are just the numbers 1, 2, 3, 4, 5. And let's say I have a set A, which contains the odd ones, 1, 3, 5. First thing I want to do is draw a Venn diagram, filling in the sets. So picture-wise, I start with my universal set. And if I compare my universal set to set A, does everybody see that A is a subset of U? Everything in A is also in U. So I'm going to draw A inside of it. So far, so good. Now, when I fill it in, I want to start on the inside in here. And so what's inside of set A?
1, 3, and 5.
5. Now, as I look at that picture, when I put the 1, 3, and 5 inside of A, did I also put that rectangular box that is my universal set?
Yes.
You're already in the universal set. So I'm only going to write them like that. I'm not going to rewrite them because this shows that those 3 elements are in the set A and also in the universal set. However, are the 1, 3, and 5 the only things in my universal set?
No, you've got 2 and 4.
And so does it make sense that I'm going to put 2 and 4 in the universal set, but outside of the set A?
Okay.
Okay. Now you have to be able to work both ways. From being given the 2 sets, is everybody comfortable drawing the Venn diagram? Can you work backwards? If you had the Venn diagram, could you look at that and say, yep, A contains 1, 3, 5, and you contain 1, 3, 5, 2, and 4.
Yes.
Yes.
Great. If that's all right, the next place we're going is like our first operation, and that's finding the complement of a set. And so we'll say that the complement of a set is a set that contains all of the elements of the universal set that are not elements of the set. If S is a set, S prime, and that prime almost looks like a apostrophe, is the complement of it. So if I were to draw a little Venn diagram, generic one, it's my universal set. Inside here is my set S. Does it make sense that everything in the universal set that's not an S will be S complement? It's the elements of the universe that are outside of the set. And so if I take that notation and apply it to the example that we just looked at, and I guess we're going backwards a little bit. I'm going to draw this in a slightly different. We said A contains 1, 3, and 5. What would be in A complement?
2 and 4.
4. Beautiful. And it's a set. Put that in those braces. And we could get A complement by looking at our rosters. Could everybody see, okay, U is 1, 2, 3, 4, 5. A is 1, 3, 5. If I take what's in A out of U, I'm left with 3 and 4. But sometimes I think that's easier to find by looking at my Venn diagram. So let's look at another example.
I got another class at 11.
What time is it?
10:52.
10:52.
We're done. Thank you for giving me a heads up.
Okay.
You had more time than that.
I love it, you know. I love to keep writing notes with you, but I got it.
Is this pacing wise going okay for everybody except that I'm too long-winded and talk too long?
Yes.
All right.
Fine.
You guys do that quiz?
Yes.
If there's anybody who showed up late after I took attendance, I'm going to stop sharing and stop recording. And